Hi guys, welcome to Sabonzi Academy. In today's video, we'll be solving the question 13 of the 2020 Nov core mass theory questions. We'll begin with question 13a. 13a, a function h is defined by h of x maps onto px squared plus qx minus 2, where p and q are constants. If the image of 1 is minus 6 and that of 3 is minus 12, find the values of p and q. So from here, they are saying that the image of 1 under h of x should be minus 6 and that of 3 under h of x should be minus 2. What this means is that if we should put 1 into h of x, we should get negative 6, and if we put 3 in h of x, we should get negative 2. So let's begin with our solution. So first, let's put 1 into h of x. So we know our h of x is px squared plus qx minus 2. So if we put 1 in h of x, we should get negative 6. So p of 1 squared plus q of 1 minus 2 should be equal to minus 6. Now we have p plus q minus 2 is equal to minus 6. Now when we send minus 2 to the right hand side, we should get p plus q is equal to minus 6 plus 2. So our p plus q should be equal to minus 4. Now we can call this equation 1. And for our second condition, we are saying that if we put 3 in h of x, we should get minus 12. So h of 3 should be equal to minus 12. So our equation will be p of 3 squared plus q of 3 minus 2 is equal to minus 12. So we have 9p plus 3q minus 2 is equal to minus 12. Now when we move minus 2 to the right hand side, we have 9p plus 3q is equal to minus 12 plus 2. So we'll have 9p plus 3q is equal to minus 10. This will be our equation 2. So you can see that we have two simultaneous equations. Now to find p and q, we can either use the change of subject method or the elimination method. But in this video, we will choose the elimination method. So for the elimination method, if you want to eliminate q, so for the elimination method, what we do is to multiply equation 1 by 3. So that the coefficient of q in equation 1 will be the same as the coefficient of q in equation 2. So when we multiply equation 1 by 3, we will get 3p plus 3q is equal to minus 4 times 3 will be minus 12. So this will be equation 3. Now let's rewrite our equation 2, which is 9p plus 3q is equal to minus 10. So we can subtract equation 2 from equation 3. So equation 2 minus equation 3. Let's change this to equation 3. And this to equation 2 to make things easy. So we subtract the whole of this from the whole of this. So 3p minus 9p, we have minus 6p. Then 3q minus q, we have 0. Then minus 12 minus 10. That will be minus 12 plus 10. So this is equal to minus 2. So minus 2. So we have minus 6p is equal to minus 2. So now to find p, we divide both sides by the coefficient of p, which is minus 6. So this divided by minus 6 all over minus 6. Minus 6 cancels minus 6. You'll be left with p. Then negative cancels negative. 2 goes into 6 3 times. So our p will be equal to 1 over 3. Now we can put p equals 1 over 3 into equation 1. So we can say that putting p is equal to 1 over 3 into equation 1, which is p. We know that our equation 1 is p plus q. So this is our equation 1. P plus q is equal to minus 4. So p plus q is equal to minus 4. But p is 1 over 3. So 1 over 3 plus q is equal to minus 4. So our q will be equal to minus 4 minus 1 over 3. So our q will be equal to minus 4 minus 1 over 3. Now minus 4 minus 1 over 3 will be equal to minus 13 over 3. So therefore, p will be equal to 1 over 3 and q will be equal to minus 13 over 3. So this brings us to the end of question 13a. Now we'll be moving on to question 13b. 13b. The function g of x is equal to x plus 1, x minus 1 is defined on the set of real numbers. Find I, g of negative 4, I, the value of x for which g of x is equal to 5 minus x. So let's begin with our solution. So our g of x is equal to x plus 1, x minus 1. And we are being asked to find g of 4. It means that anywhere we see x in g of x, we put negative 4. So g of negative 4 will be equal to negative 4 plus 1 times negative 4 minus 1. So negative 4 plus 1, we have negative 3 times negative 4 plus 1, we have negative 5. Negative 3 times negative 5, we have 15. So g of negative 4 will be equal to 15. Now moving on to I. It says that find the value of x for which g of x is equal to 5 minus x. So g of x is equal to 5 minus x. But we know that our g of x is equal to x plus 1, x minus 1. So we can say that x plus 1, x minus 1 is equal to 5 minus x. Now we can expand to remove brackets, and when we do, this will multiply this, this will multiply this, this will multiply this, this will multiply this. So we get x squared plus x minus 1, which is equal to 5 minus x. Now positive x will cancel negative x. We'll be left with x squared minus 1 is equal to 5 minus x. Now when we move everything to the left hand side, we have x squared plus x minus 1 minus 5 is equal to 0. This will give us x squared plus x minus 6 is equal to 0. So now we factorize. We find factors of 6 that when we multiply, we get negative 6. And when we add, we get 1. So for our factors, we pick 3 and negative 2. So let's see. 3 times negative 2, we have negative 6. And then 3 plus minus 2, we have 1. So our factors will be 3 and negative 2. So our equation becomes x squared plus 3x minus 2x minus 6 is equal to 0. So here we group this and this, this and this. Now when we factorize x out from here, we get x out, x plus 3 minus, so we can factorize 2 out from here. So we get 2 multiplying x plus 3 is equal to 0. So we have x minus 2, x plus 3 is equal to 0. So x minus 2 is equal to 0. And x plus 3 is equal to 0. So x will be equal to 2. And x will be equal to minus 3. So the values of x for which g of x is equal to 5 minus x is 2, and negative 3. So this brings us to the end of question 13 and to the end of the 2020 Nov Core Maths Theory questions. Now, don't forget to like and subscribe for more content. And don't forget to leave your questions and comments in the comment section as well.